Hello Legacy students, Mersh here. So today we're going to talk about how to factor a quadratic equation. What you're going to want to have on you, pencil or pen, that foldable that we made in class, a calculator, maybe just to do some like simple math, and then definitely pull on those thinking caps today. So first thing we need to make sure we know how to do is how to multiply. Okay, I know, seems rudimentary, but basically for multiplying, remember guys, it's basically just like double distributing. So I'm going to distribute the x into both of them and then the 3 into both of them, okay? So we would get x squared minus 1x plus 3x minus 3, or we get x squared plus 2x minus 3, because I combine these two like terms, right? Same thing here. Do my double distributive. So I'll get x squared minus 3x plus 3x minus 9. Now notice guys, these two are going to cancel out, which is totally cool. So I get x squared minus 9 in that one in particular. So here's where you want to find that factoring foldable that we made in class today. Okay. So open up your first tab, and we're going to talk about what does it mean to factor. Well, factoring is basically the way to find out what was originally multiplied to create the expression. Basically what you're doing is undoing the distributive property, or you're undoing that multiplication process that we just did on the last slide. So we're basically trying to find what two things multiplied by one another to get the original expression. So one particular kind of factoring is called greatest common factoring. You might have heard that more commonly termed as GCF. GCF, basically the question you're going to ask yourself is, what is the largest number and or variables that can be divided out of each term in the expression? So we got a couple of examples here. So I'm going to first see what number can I divide out of a 6, a negative 12, and an 18. And I want it to the biggest number. Well, a 3 can go out of all of those, but definitely a 6, right? We could definitely take a 6 out of everybody. Can everybody have an x divided out? No, right? Because this 18 doesn't have an x. So if I divide out a 6, literally what I'm doing is I am undoing the distributive property. I'm thinking, what can I, if I would take a 6 out of every single one of these, divide out a 6, what's going to be left behind? So I'll get an x squared left behind there, a negative 2x left behind, and then a 3 left behind, right? So let's try example 2 here. So I need to see what can I factor out of both of those terms. Let's check for numbers first. So 14 and 7. Looks like we can take 7 out, right? And then they both have an x in there. So I gotta see what's the largest number of x's that I can factor out of both of them. Well, this guy has 4, this guy has 1. So both of them can give 1x, right? So now I need to think, what would be left behind? Well, 2 would be, right? Because 7 times 2 is 14. I have 4 x's, but I took 1 away, or 1 out, so that'd be 2x cubed. 7, this is about to be a 1. And then I took that 1x away, so it looks like it'd be 2x cubed minus 1 that would be left behind in there. Correct? And then for example 3, I'm going to have you try that one on your own. Once you find it, see if we'll go over it in class. Group factoring, that's when you have 4 terms. That's the only time you can factor by grouping. So first thing you're going to do is you're going to group them into pairs, and we're going to factor out the GCF of each group. Then we're going to factor what is in common one more time. Let's try it. So let's group them into pairs here. So we're going to group and group. Okay, that's why it's called factor by grouping. And then we got to pull the GCF out. So It looks like 2x would be the GCF for the first guy, first pair, right? Left out of there would be x squared plus 6. Yep. What's common between these two guys? Looks like it would be a -5, right? Oh, hold on. Just realized we can pull out an x squared. Whoops. This should be 2x squared, right? Because they both have a x squared in there. Didn't see that x squared. Okay. This one I could pull out an x plus 6 would be left behind, right? So now I need to find what's in common between this term here and this term here, because they're multiplied. That's why it's 2 terms only. Well, x plus 6, right? They both have this x plus 6. So if I factor that out, I'd be left with a 2x squared here, right? And a -5 there. So I have factored this 4 term back down to this in particular. Let's try another one here. So, combine these two, group into pairs. So what's common between these guys? It looks like it'd be a 2x, right? We'd have an x, oh, nope, actually 2x squared, right? Just literally can't see that x squared today. And then x plus 2 would be left behind after I factor out a 2x squared out of both of those terms. What is common between an x plus 2, an x and a 2? Nothing, right? But technically they have a 1 in common, so we're going to factor out a 1. Now notice, guys, these match again. That should always happen. If that does not happen, we have a big problem. You need to always make sure that the second guy, the guy in the parentheses, matches for factor by grouping. If it doesn't, that means A, you messed up, or B, it's not factorable, okay? So factor out my x plus 2. I'll be left with 2x squared plus 1. That last problem, I'm going to have you pause the video right now and go ahead and try that problem alone. Okay, so try that one and then restart the video. We'll go over the answer in class. Trinomial factoring. Depending on what classes you've taken, you've probably seen different versions of trinomial factoring. We're going to talk about guess and check on this. It's going to be a lot easier and it's going to make you a lot quicker factoring person. So first thing you're going to do is write 2 sets of parentheses. Then we're going to ask ourselves, what 2 factors multiply to make the first term? Then we're going to ask, what 2 factors multiply to make the last term? And then finally, we're going to try different combinations until when we multiply, we receive the original problem. So let's go ahead and try these ones. So I need to write out my 2 parentheses. Okay, and I need to ask myself, what 2 factors, what 2 things make x squared? Well, an x times an x, right? So I'm going to put those guys in the front here. And then I'm going to ask myself, what 2 numbers make 6? Well, 6 and 1 make 6. 3 and 2 make 6, right? So let's check. I'm going to try a 6 and a 1. I also know that these could be also negative, right? So let's try, I'm going to try positives. So, let's refactor. Basically, I want to see, do we get a 7x? So I'm going to multiply my outsides and my insides to see if I get 7x. So 1 times x is 1x, 6 plus x is 6x. 1x and 6x makes 7x. So it looks like I am completed. I have factored that equation. If I would have tried a 3 and a 2, we would have gotten 5x, which wouldn't have been right? So we need to always check, once we plug in some numbers, check to see, do you get the original back out? The main thing you're looking for is, does that middle term come out of the outside and the inside multiplications. Let's try the next one. So I got, actually, you guys can try that one on your own. It should be very, very similar to example 1. Let's try example 3, because notice, this one's a little different. There's a 3 sitting out there. Well, I've got to put my two parenthesis sets, and I got to ask myself, what two numbers make 3x squared? Or what two factors? Well, a 3x and an x, right? So I'm going to put 3x here and an x here. Then I need to ask myself, what two numbers will make -2? Well, there's only 2 of them, right? That will make -2. So now, here's where guess and check needs to be a little, gotta kind of check it. So I'm going to put a -2 here and a +1 here. Just going to see if it works. So 3x times 1, that's 3x. -2 times x, that's a -2x. Oh, goodness, I got it to be an x. That's positive x. So this is correct. Now look at what would have happened, however, if I would have tried the other way. So if I would have said, well, let's check to see, maybe this is a -1 and that was a +2. So if I would have multiplied 3x times 2, that's 6x. This is a -1x. That would be a 5x, not the middle term that we wanted, right? So that's why I couldn't have used the -1 and 2. It's not, when I remultiply out, because that's all you're doing is factoring, is just undoing multiplication, we need to make sure we get the original back. Let's try 2 more. So I need to find 2 numbers that multiply to give me 5x squared after I put my 2 parenthesis sets. Well, there's only 2 things, right? 5x and x. Now 18. 18 has a significant amount of factors. We can go 1 and 18, 2 and 9, 3 and 6, right? And changes of signs. Now it is -18, so we know one's going to be negative, one's going to be positive. And I'm trying to make a -1 in the middle. Let's try a -6 and a +3. Well, that's going to be -30 plus 3x. Oh, Lord, that definitely is not going to make a -1. So let's do a switch swap here. Do some changes. Let's try, well, a 2 and a 9 might be able to do it for us. Let's try a 2 and a 9. Well, this would be 10x and that would be 9x, right? And if I make this a -10x and that's a +9x, I'll get a -x out of that. So that must be my factored, because I'm -10x plus 9x, that is 1 -x. But 9 times -2 is still -18. So keep that in mind, guys. That does work. You just need to try. Guess and check is frustrating because of the need to check everything. If it doesn't work, sometimes you just need to check it. Another hint to be aware of is you always want to look to see what this term is. That tells you if you have a positive or negative, or if you have 2 negatives or 2 positives. It all depends on what's going on. So I want you to try example 5 on here on your own. We'll do that one in class as well so you can check your answer. Last kind of factoring, difference of perfect squares. This is only when you have 2 terms. Okay? Now, difference of perfect squares has some criteria, some conditions that you have to follow. So first you're going to check to see, do you have a difference? AKA, are you subtracting? If you're not subtracting, you can't use this method. You also want to make sure you have perfect squares. So we're talking 2, or we're talking 4, 9, 16, 25, 36, any of those numbers, okay? If you don't have those numbers, this is a no-go. We can't use this method. Then we're going to use it to factor into 2 factors, one positive, one negative, okay? So let's check a couple here. So I got x squared minus 49. So first thing I'm going to check, two terms, check that off. It's a difference. We're subtracting. X squared is a perfect square, 49 is a perfect square. So now, here's what I'm going to do. I'm going to make two parentheses. Basically, kind of like trinomial factoring. Two x's make x squared, right? And then numbers that make 49, I'm pretty sure it's only 7 and 7. But I need a 0 in the middle, right? So that would make 0, right? Negative 7x plus 7x, that's going to make 0. There's no x term in there. That's always going to happen on a difference of perfect squares. You're going to have x, x, number, number, and one's going to be a plus, one's going to be a minus. So like on this one, double checking, both of them are perfect squares, and there's subtraction in the middle. So I need to ask myself, what two things make 4x squared? Well, a 4 and a 1, but a 2 and a 2, right? Because we're going to use the perfect squares idea. They need to match perfectly, except one's going to have a plus in the middle, one's going to have a minus. So I got 2x and 2x, and then 3 and 3 for that 9. Let's try this one. Both of them are perfect squares, and we have subtraction in the middle. So immediately I know I can jump to that particular way. Now notice this one is a little flipped. These need to match, so I need to think, what number times itself gives me 81? Well, that'd be a 9 and a 9, right? And I got a W and a W. Let's try example 4. Two numbers here. This is perfect square. That's perfect square. There's subtraction in the middle, so we're good there. I got 4x and a 4x, right? Because those two multiply to give me 16x squared. One positive, one negative, and then a 5 and a 5 to make 25. I'm going to have you do 5, 6, and 7. I know. Holy buckets, Marsh. Asking a lot. But try those ones first. See if you can get those answers. We will go over them in class. Thank you for watching this stupidly long video. I know it is stupidly long. However, factoring is so important as we continually go forward. That's why we're making sure we hit it hard for these couple of days to make sure that we can factor as the year progresses and beyond this class. Trust me, factoring continually shows up and it becomes a skill basically as simply as adding numbers. So make sure you focus on working on your skills in factoring. But with that, I want to say, see you later, Sabers.